So, continuing with the syllabus, now we are going to study about the arithmetic circuits. Arithmetic circuits are nothing but your half full adders and subtractors. So, like I said, if you study one, it's more than enough to write the another one. So, if you study the adder part, so it's all same in the subtractor part. So it's not that difficult or anything like that, and everything is same itself in both adder and subtractor, except for one small slight change that we'll be seeing now itself. So as you can see here, there is a definition of half adder. It's very simple. CS means combinational circuit. Okay, so a combinational circuit that performs the addition of two 1-bit binary number. Two 1-bit binary number is what? So as you can see here, it can either be, this is one bit one number, and this is another one binary number. So 1-bit number, and so two we are adding, right? So we are adding this bit and this bit. So 1-bit binary number. So you are not even saying directly 0 and 1, because it will be only 0 and 1 addition, it will be like that. So we are saying two 1-bit binary number and producing the sum and carry of it. Why sum and carry? So you can recall from your childhood classes, this first standard, LKG and all. So when you used to add numbers, how they used to teach, if you add number, you will usually get carry, right? So you will write in the left hand side above like that. So that's why we have carry over here. In the same, while subtracting, you will borrow one number from the left number, and you will borrow from there and write. So that's how these terms mean. Sum means the addition of this, what is the value we will get. Carry means this. So how to add or add this or subtract this? First, I'll explain you how to add the numbers here. So whenever you have this number, so let us take example of this itself, 0 0 0 1 1 0 1 1. Okay, so you have to add 0 plus 0 is usually 0, right? So your sum will be 0 itself, and 0 plus 1 is 1, 1 plus 1 0 is 1 itself again. So don't write 1 plus 0 is 0, don't get confused. So 1 plus 0 is 1 itself. Now coming to this 1 plus 1 part. So how to add this 1 plus 1? If you add this 1 plus 1, so you will have one carry obviously. How this happens means, so 1 plus 1 you do. So when you add 1 to this, so this 1 plus 1 becomes 2. So how 2 is written in this 2 is written like this in binary form. 1 0 is your 2. So if you say 1 0, so this thing will become your sum, and this will become your carry. It's very simple to understand. So you know, right, 1 plus 1 is 2, but how do you write 2 in your binary form? That is 1 0. It's 1 0 itself, right? If you have 3 variables, suppose 0 1 0, so what is the value of this? 2 itself, right? So like that itself, only 2 variables are there, means it will be obviously 1 0, like this. Say this 1 0, what is the value of this? 2 itself. So this is 0 1 2 3. So don't take values from here. I am just showing you how we write 2. 1 plus 1 is 2. How we write 2? Like this. So write sum, the right thing is your sum, and this is in your carry. So just write 0 here, and here carry part, right? This was your sum, and this was your carry. So carry, we didn't get any carry here. It was 0 0 0. Only here we got one carry because it went there. So we will write here. Whenever you have 1 plus 1, directly write off carry. That's your main thing in this to know. So let me do for 3 variables now itself. So here we have for 3 variables, you have 0 0 0. So 2 3 4 1 2 3 4. Okay, so now you will have same sum and carry itself for this also, sum and carry. Now you can see here all are 0, it will be 0, no carry. Only 1 1, 0 plus 0 plus 1 is 1. Here for till here, this is also 1. So carry is 0. Now you see here 0 plus 1 is 1. Now 1 plus 1, whenever you get 1 plus 1, first write off 1 in your carry, then write 0 here. Simple. I told you, right, 1 plus 1 is 2. How we write 2 in your thing? If you want, you can just change the column like this. So let me do like that. So that will be even more easy for us to write. So if I write carry first and then sum, so that should be, so 0, it was 0 here, all over here, and this was 0 1 1, right? See, now you got 1 1, so just write 1 0. Now here only 1 will come, because 1 plus 0 is 1, again plus 0 is 1. So sorry, okay, so sum is 1. So here again, so you have 1 and 1, so 1 plus 0 is 1, so again you write 1 plus 1, so just write off 1 0 like this. Okay, here also 1 0 like this. Now you see here you have 3 ones. So how you will do that? So 1 plus 1, yeah, you will get carry over here. So this becomes 2, right? So here again first write carry in advance. Now as you know, you will be having 0 over here now. If you add 1 plus 1, carry went 1. So you have 1 carry, but this thing will be 0, right? So like I said 1 0. So your sum will be 0. So now 0 plus 1 is 1. So why you get 1 here is simple. So when you add these two number 1 plus 1 you get like this. Okay. So that carry went here. That carry we wrote off here. Now this presently is 0. So 0 plus 1 is 1. So that's how you write over here. Now let's move on with the theory part. It's not much theory, just you have to put the K map. Like I said in the previous sum you saw, right? So this is one sum and this is one carry. We have to draw a K map here. As you can see, I have written for sum you had only 1 and 2. Okay, to explain you in better way, summation 1 comma 2, that's all you had for sum, and for carry you had only summation of 3. Summation of 3, that's it. So now you can see 1 and 1. So it's isolated. So how you write the variables I have written here. So this is isolated. You will have a bar and b, and then you have this a b bar. So you got a b bar plus a bar b. So you know that in the first model you saw this is nothing but a exclusive b. So we got a sum as this. Now for carry we had only this. So a b. So our carry is only a b. Since we get here and that is a b. So we get a b. That's it. Now what you have to do? You have to draw the logic diagram. You know the XOR gate will give you the exclusive value. So this nothing but a exclusive. This symbol is exclusive symbol. So you can use this gate or you can use the basic gate also. It's not like you have to use this, but you can use this. But you cannot use this gate in Verilog HCL programs, because there you have to use the basic gate itself. This is easy to write here. So this is just your half subtractor. So this thing completes the half. First what we do, we had to draw a box here first, okay, and mention in that half adder. Sorry, it's a half adder. Simply give two inputs and here add. So here give a b sum carry like this. So then you can start with the truth table, followed by the K map, followed by the logic diagram. The same thing now. This was half, right? So we will see the full adder. So what happens in full adder is we have 3 bit. This was only 2 bit, right? So we will go with 3 bit. So I explained you the truth table also. So we will having the diagram will be like this. So 1 2 3, but your output only 2, sum and carry. Sum car. We will have here a b. I won't just write c here, because I will write c in here. Okay, carry in. C in means carry in. Okay. So this I will write c out in the output side. Okay, so carry out, this is carry in and this is carry out. So I will write a b c, and then I will write carry, and then I will write sum. So as you see, you know here 0 0 0 0 1 1 1 1. This side inputs are always the basic truth table you have to put. So let us do that first. 0 1 0 1 0 1 0 1 over. Now in the carry side, so here all are 0. So 0. Here sum will be 1 and here sum will be 1, carry is 0. Now 1 1 you got, just write 1 0. Only 1, right here 1, this is 0. You got 1 1, put 1 0, and here 1 1 1 0. All are 1s, then just put 1 1. Simple. So if you want to, if you understood how to add, it's more than enough. If not, just see the order here. You will get 0 1 1 0, then 1 0 0 1. So for first 4, 0 followed by 2 1s and 0, then again 1, 2 zeros and 1, and for carry also just see in the middle part here, it is 1 0. So remaining is all 1, above it's all 0. So just try to put in your mind so that you can understand, remember. Suppose even if you go wrong in your addition, you can cross verify by this technique. Okay. So now you can see we have to put K map. So for understanding purpose, I will put you the summation M. So you will be having for 1 2 4 and 7. 1 2 4 and 7. And for carry now we have only 0 1 2 3 5 6 7. Okay, this is 3, 4 is not there, 5 6 7. Now for this you have to draw the K map, and again here is only 3 variables. So so for half adder we did for only 2 variables, so we will have only this box for the K map. If you are doing 3 variable, we will have this like this. Okay, and let me do for carry over this side. Okay, so 0 1 3 2 4 5 7 6 it's visible, right? Yeah, 0 1 3 2 4 5 7 6. So for this sum, right, 1 2 4 7 1 2 4 7, again you can see you get all isolated ones. And now for this carry, you will get 3 5 6 7, you will get like this. So you will have one pairs like this. Okay, so now what will be the equations for this? So I'll generally like the equations because I won't be wasting time on all those things. So for one by one I'll just write the equation. That will be a bar b bar c in, then a bar b c in bar plus a b bar c in bar, then you will have only a b c in bar, I mean a b c in. And remember, while you put here only a will be there, here b and c in, so don't forget to mention c in. So plus, so this was your sum equals to like this you have to write, and carry equals to ab plus bc plus c in. So this is your carry equation, and this is your sum equation. Now what you have to do, carry just you can keep it as it is, how it is, but for some part you have to explain it. So let me write it once again over here. Now you see, I'll write in order wise, a b c in, this I wrote first, then I'll write this a b bar c in bar, then plus I'll write a bar b c in bar, then I'll write a bar b bar c in. So now you can see here, now here you can see this b c in bar and b bar c in. So now just letters has changed, but the concept is same. I'll explain in this small place here. You know, right, a b bar plus a bar b is equals to a exclusive b, right? So if you just change these letters, the same thing is here, right? And another thing which I didn't say in the earlier lectures, and if you have this one for each one term alternative bars, but here a b plus a bar b bar. So what is this? This is also a exclusive b itself, but you will have a bar on that, whole bar it will be. Okay. So now you can see you can take a common. So what you will have, b c in plus b bar c bar in, plus now you take a bar common. So what you will have, b c bar in plus b bar c in. Now again this thing you know and this thing you know, this will be b exclusive c in, and this will be b exclusive c in the whole bar. So just write that a into b exclusive c in the whole bar plus a bar into b exclusive c in. Again to cross verify if you are doing right. So here if a has bar, so here inside there won't be bar. If a doesn't have bar, inside there will be a bar. So that is one common way to understand. And now this is very simple. From this further, so here a bar and this if you take this common, so you will get you cannot take common. So the next step is simply to write a exclusive. So how this is, right? See, you consider this as one term and this as one term. Now you can see again this is in the form of a b bar plus a bar b. Okay. So this again you can write. So this will simply become like this: a exclusive, b exclusive, c in. In simple terms to make you understand. So this is in the bracket. If you remove the bracket also, it's same. Okay. Then plus here you will get, yeah, that's it. This both the things if you add, it will be like that itself. So that's it, how you write explain this. So this is the explanation for like carrying. Now you have to draw the logic diagram for this, and you have to draw the logic diagram for this also. So for this either you can draw you have to draw logic diagram for this all four expressions also, and at the end you can draw like this. So as you can see here, for carry I have drawn the logic diagram here, and if I push it up, so now you can see this, there is a logic diagram here for the four expressions. So you can see this logic diagram, take a screenshot or snap of it and just see how to do. If not the easy logic diagram, you can simply you cannot draw logic diagram like this. Okay, why you cannot draw logic diagram? It will simply give a exclusive, b exclusive. No, you cannot draw because XOR cannot take 3 inputs, it can take only 2 inputs. So if you want to draw, what you have to do, give 2 inputs first, then additionally separate, give like this another XOR, use 2 XOR gate, and then here you can give A, B, and here you can give C. So you can draw like this also. So this was how you do your full adder. Now there is another concept here in which you have to use. Now you saw full adder was this, so you have to mention FA full adder here, and you saw half adder here. So half plus half is full, you know that, right? So there is another concept here which says using two half adder you have to with one OR gate, okay, one OR gate and two half adders you have to use and write. So it's simple. What you have to do, you just write the heading using full adder using two half adder, and yeah, that's it. Just write the sum like this, okay. Sum equals to what, you know, write it off. Now coming to the carry out part, you have to extend this AB plus AC in plus BC in you had. So what you have to do, keep this as it is, first letter AB as it is. In these two terms, what is missing, you have to multiply that term with its complement. The way we did to find SOP equation, right? The same way add here, like see here B is missing, so multiply B plus B bar, here A is missing, multiply like that. So if you extend, you will get equation like this. Now what I did, so you can see here in this 3, 1, 2 and 3, you have AB common. I took AB common, so 1, I took this, if I take AB common, this will be 1. So here only C in will come, C in will come over, plus this remaining 2 I have written as it is. Then I wrote what I will get, 1 plus anything is 1. So AB into 1 is AB, only AB. So this whole thing will get reduced, it won't be there. Now here you can see C in is common, take C in common, what you will get, A bar B plus AB bar, again it is in the form of that exclusive, so it will become A exclusive B. So just write this as it is according to this equation. Now you have to draw the whole diagram. So this will be your full adder diagram using two half adders. So now ultimately what you want to do, you have to get this equation in one side and this equation in your one side. So that's what here, sum equals to, we got that here, and carry equals to, C out equals to, that we have got. How to do this? So first basically you just draw, okay, let me explain you, just see the diagram here, I will explain, I will show you how to do this easily. So first what you do now, first do the sum part, okay. Sum you will get like this, this is A, B. Now take C in and finish the sum part, okay. So C in will come like this, right. So this is your C in. So what you got here, you will get here A exclusive B. Now here you will get A exclusive B exclusive C in. First finish the C in part. Now what you want is the carry part. See in the carry part what you have AB. So you want to make AB now. First then make AB, then A B, using AND gate you got AB. Then what you have to do, C in into A exclusive B in. So you have C in line here and A exclusive line here. So take them separately like this, this like this, and multiply from AND gate. So what you will get here, C into A exclusive B in or A exclusive B into C in, both are same. Now what you do, just add this both AND gates with one OR gate. So what they have mentioned, use one OR gate, right. So this is the only thing you have to do here. Now the interesting thing is, now you completed about adder, right. So in subtractor everything is same. The only difference which we encounter in subtractor is that you will have one bar over here, A bar B. So here you got A B. So in subtractor you have bar over here, and if you want to have bar, what you have to do, you have to put one NOT gate here, right. So only this thing is the difference. I will show you the picture. So from picture itself you can understand and write for subtractor. But I will explain you how to subtract these decimal numbers once. So in binary adder you saw how we add the numbers. In subtractor, as I said, if you subtract, if you don't have the greater number, you will borrow it. So let me take example of two variables itself, 0 0 0 1 1 0 1 1, okay. So now I'll here I'll put borrow, and here I'll put the difference, okay. So now see here, 1 minus 1 is what, 0. 0 plus 0 minus 0 is 0. So here we didn't borrow anything. So first and last aram se we could say it's 0. Now in this also, see, if we do 0 minus 1, then we have to borrow. But for 1 minus 0 we don't have to borrow. So 1 minus 0 is what, 1. So your difference will be 1 here. Now coming to this part. Now you have to borrow. If you borrow, what will become 1? So since you borrowed, right, so this 1 here, whenever you take, just forget the left and right side. So this thing holds the value of 2 now. So if you subtract here from 1 like this, So that will be like if you do, so like see 1 minus 1 if you do na, so you will get uh, 2 minus 1. So now you have to borrow 1, okay, then 1 minus 1, 2 minus 1, again you will get 1 here. How you get 1 here difference? Because this thing will hold the value of 2. So this bit na here, so left hand side it is there, so if you borrow, that will hold the value of 2 now, and you subtract from 2 1, so the difference is 1 itself, so that's why you write 1 here. So one, let me just cross verify half subtractor. So as you can see here, difference is 1 1 itself. So if you do for 3 variables once, we will get a clear idea. So let us do that. Okay, here I will put borrow, then here I will put difference. Now see, first is 0, right, all are 0, so then it will be 0. 0 minus 0 is 0, again now 0 minus 1, so we need to borrow here, so directly put borrow 1. So if you borrow 1, only 2, 1 minus 1, you will get 1 itself, okay. Now in this thing, 0 minus 1, again you have to borrow here. So what will be remaining here? 0 minus, so 1 will be remaining here, okay. So you know, right, so if you borrow here, that will become 2, so 2 minus 1 is 1. So again 1 will be remaining here. Now 1 minus 0 is 1. Now here 0 minus 1, you have to borrow here again. Now since you see, after borrowing, this becomes 1 here. So 1 minus 1, this should be will become your 0 here. So how this is happening? Like I said, once you borrow, right, this bit will hold value of 2. Just think like that. For understanding, I am saying like that. So if you borrow, this 0 will get 1, right, that 1 will hold the value of 2. So 2 minus 1, so this bit value will be 2. So 2 minus 1 is suppose if I have to explain this clearly, I will just explain this part. You borrowed, right, so you have here 0, you have to subtract 1. So what did you borrowed? If you borrow, what will become? Like this, okay. So this is your 2, this is your 1, 2 minus 1 is what? 0 1 itself again. So like that you have to write, okay. So now over, so this will be your 0 1 1, right. One more thing, difference. So difference over here you will get 0, like I said. So why it will be 0? When you took borrow, this become 2, 2 minus 1 is 1. So what value was remaining? That was 1. Now 1 minus 1 is what? 0. Now coming to here, 1 minus 0 is 1, again 0. So you can simply no borrow, so difference is 1. And here it is also easy, 1 minus 0 is what? 1. Again 1 minus 1 is 0. So we didn't borrow anything. So here 1 minus 1, 0 directly. So here 1 minus 1 is 0. So this thing is 0 now. So 0 minus 1. So you have to borrow 1, and your difference also will become 1 over there. So this is how you subtract. And again here also you have, you see, 0 1 1 0, 1 0 0 1, similar to that thing. And in carry part, what you had here 1 0, remaining down all are 1, and up above all were like that. But here again you have like this. So first and last will be your 0 and 1, then 3 1s and 3 zeros. So that's how one way to understand or to remember. So now we finish about how we subtract or something. Now let us move on to the theory part. So let me write here. Now how we will do half subtractor, we will write, okay. Half subtractor, you have to difference, write full in the examination. Here borrow, in what you have 2 inputs, A and B. So now like we saw, see this here, I won't be doing everything here because we already studied adder, right. So that's same itself. So in difference we have 2 place 1, and borrow only 1 place 1. So in the cell number of 1 and 2, here 1 and 2, it is same. So difference is same as the sum in adder, half adder. So half adder, half subtractor, it's both same. So we will get A exclusive B, the difference. But in the borrow part, what is happening? We are getting 1 here. In carry part, we got 1 in this place, but in difference we are getting 1. So we will get A bar B. So only difference is you will get 1 not gate here. So like I said, 1 not gate is extra over here. Similarly, moving on to the subtractor part, just see here. So I will write summation m for borrow ones. So what we will have? 0 is not the 1, 2, 3 and 7. summation m for difference, this is for borrow. Okay, for difference what you have 1 2 4 7, this for difference. From this do the k map, so you can see here. So the same thing you will get same to same difference here also for full subtractor as you got in full adder. As you can see, same thing, right? Just write the same thing here again, and only the thing here changes in the subtractor part. So we got this two pairs down, here it is up. So what will the equation for that? Just equation is also the same, AB in. So we had the AB, AC and BC, right? So in place of C in we have B in, just A will get bar over all the places. So that's the only difference here. Here A will get the bar. So I'll just show the comparison. So you got AB plus AC in plus BC in your carry. In borrow what you are getting here, A bar B plus A bar B in we had, okay, plus B C B B B B in, okay. So this is the only thing which is changing here, okay. You can see the difference, make out the difference. So remaining everything is same. We have to just write this difference part once again, like I have shown here. Just say this is reverse, right? Okay, how you wrote same to same in full adder, same thing just write for full subtractor also. So now coming to the another part. So we saw for full adder and half full subtractor and half subtractor. This is a logic diagram for that borrow part, difference, that equations. Then for borrow how you get here, okay. Now you have to write full subtractor using two half subtractor, the same thing. So like I said, so nothing is changing here, only one thing that changes is your borrow part. You have here in the equation only bar, right? So A bar B plus B B in plus A bar B in. Same thing you do here, what you keep A bar B as it is, just you have to add here. See, I will write once again, I will do once again here. So what is missing? A is missing, right? B into B in into A plus A bar you do here, which is missing? B is missing. Don't get confused in B and B in, okay, both are different, okay. So what you will get, A B is as it is. Now you will get A B B in plus A bar B B in, here again plus A bar B B in plus A bar B in. Now you see here, this term and this term you can take common. If you take B in common from this term, let me write that first, okay. I will write here, see, B in I took common. So what is remaining? A B plus A bar B bar, right? Now in these two terms you see, take B in common again, okay. What you get? A bar B plus A B bar, same thing, right? So A bar B plus, now what you will get? B in into A exclusive B plus B in into A exclusive B the whole bar, okay. Now again you can reduce this as we did in half subtractor here. So here actually here I forgot to take A bar B common first, okay. So I did that mistake, see here, I forgot to take A bar B common. So wait, let me correct that, just this will go like this. So see here, A bar B here, and here A bar B, if I take common, same thing you are doing, 1 plus you will get B in plus B in. So I will write the remaining thing then. So I will have A bar B B in, not A bar B, A B B in plus A bar B in, okay. So I did this mistake, don't go like that. I forgot to take A bar B common everywhere, same like we did in full adder using two half adders. So same thing, now A bar B will be, this whole thing will become 1, okay, it will become 1. So here take B in common plus B in common. So you have here A B plus A bar B bar. So that is nothing but B in into A exclusive B the whole bar, okay. So here A bar will come. So same thing you have to draw the logic diagram. So I will draw the logic diagram once for you here. I'll draw it like this itself and show you. So you will see, as you saw in the equation, I'll write the equation once again here. You have a bar b for difference, okay, sorry, for borrow, a bar b plus b in into a exclusive b the whole bar. So just see, same equation, only two places you will have the NOT gate. So I'll draw the same diagram as we did, or else just let me show here. Same diagram you have to draw. I will do in the pencil part, okay. So what we wanted, see, this is the equation above here you have, and here see a b you want a bar over here. To get a bar, what you have to do, you have to give one NOT gate here, okay. Just give one NOT gate here, same diagram. Now you have a exclusive b going here, right? So give another NOT gate here. You will get bar over here, and you will get bar over here, and finally you will get like this. So this is your diagram for full subtractor. So this is it for your arithmetic circuits. Very simple. If you don't understand, just watch again, you will understand easily. Just speed up the video and finish it. So thank you. And in next video we will go for multiplexer, demultiplexer, and how to solve those things. It is also dead easy, very easy. I will complete only till combinational circuits, and I will give the definition of sequential circuits, because you can leave one topic, right. So I'll be leaving that part, so you don't have to worry much. So that's how this is there. So I'll explain you till coder and all, and how to solve some sums. I'll solve one or two questions from the question paper, so that you can understand how to solve that if they give any particular numbers or sums. Thank you.